Okay, today what we're going to do is take a look at inverse functions. And if you recall from Algebra 2, to find the inverse, we're going to switch our x and y's. So for part A, let's take, this is going to be our function, and let's take a look at our inverse. So for our inverse, let's just take each ordered pair and switch the x and y. -1, 2 goes to 2, -1, and 4, 7 goes to 7, 4. Okay, so from the function, the domain of my function is going to be 2, 3, -1, 4. The range of my function is going to be 5, 6, 2, 7. Now let's take a look at our inverse. The domain of the inverse is 5, 6, 2, 7. And the range of the inverse is 2, 3, -1, 4. Notice that the domain of the function becomes the range of the inverse. The range of the function becomes the domain of the inverse. That happens because we switched x and y. For part B, we want to write the equation for the function and its inverse. So the first thing I want to do, it's a line, so let's find our slope-intercept form. For the function, the slope is 3. The y-intercept is -7. For the inverse, I'm going to switch x and y and solve for y. So I'm going to divide each by 3. And let's just always write our inverse notation as such. All right, I know I'm not supposed to box it, but just so you can see the difference. Now, graphing the inverse might be a little more challenging, so always make sure you label your functions. So what I might do is, under my function, my ordered pairs are 0, -7, and another good point, maybe 2, -1, and 3, 2. Those on my function, on the inverse, will be switched to -7, 0, -1, 2, and 2, 3. So take a moment and plot those. And now that I plotted my inverse, make sure you always label each function. And remember, the relationship between the function and its inverse, they are reflected over the line y equals x. So that was a preview of what you had done in Algebra 2. Now let's bring it to the calculus. If I'm giving the function, a cubic function, f of x is equal to x cubed plus 2x, I want to find the inverse. So you would think you would switch x and y. So that would be x equals 3y cubed plus 2y. Now the question is, how do you get y by itself? If we factor out a y, we still have y within the parentheses, and we can't get that by itself. So this will not work. So one thing I'm going to start with is, let's go back old school. So let's take our ordered pairs for our function, and that is -1, -5, 0, 0, and 1, positive 5. Let's graph those on the inverse. 1, 5 will go to 5, 1, 0, 0 stays 0, 0, and negative 1, negative 5 will go to negative 5, negative 1. And go ahead and graph those. So now that we have it graphed, let's investigate what is happening with our derivatives. Since I can't solve for the inverse, and remember my goal is to find the slope of the inverse at 5, we have to be creative. So to do that, I'm going to look at this value 5. On the inverse, this is the x value of the inverse. Well, that really means it's the y value on the function. So I need to think to myself, where was my y of 5? On my function. So let's go over to our function, and that would be in red, my function is a 5 at 1. So what I want to do is take the derivative. If I'm looking at the slope of my function, I want to find the derivative at 1, which is up here. How do I find the derivative? That's easy. So I can take the derivative of my function, and let's see what our derivative is at 1. Again, I'm choosing 1 because that was the ordered pair that helped me get the 5. Okay, so the derivative of f at 1 is 11. Since we can't find the inverse of f, let's go ahead and set it up for the inverse. So let's switch our x and y. And we can still take the derivative using implicit. So this will be 1. Don't forget the dy dx. And now we want to solve for dy dx. So now since I'm doing the inverse, I want to take the derivative, evaluate the derivative at the point. Since I'm on the inverse, 5, 1. All right, substitute that and see what you get. So the derivative of the inverse turns out to be 1/11. The derivative of the function was 11. What's the relationship? They're reciprocals. Interesting. So let's take one last time. We have our function is f of x equals x squared plus 2. It is a parabola, but in order to have an inverse, it has to pass the horizontal line test. So therefore, we are going to restrict our domain from 0 to infinity. So let's first find our domain of our inverse. The domain of f is going to be 0 to infinity. The range of f is going to be 2 to infinity. So now I know the domain of my inverse and the range of my inverse. I know those because I can switch from what I know about the function. All right, so let's find our derivative at 1. So the derivative is 2x. The derivative at 1 is 2. Now let's find our inverse. We're going to switch x and y. and solve for y. Remember, when I take the square root, I have to have plus minus. So the inverse is really plus minus square root of x minus 2. But because I have restricted the domain is, the range is 0 to infinity, I only want the positive. So if we graph that, and remember to label your graphs, function is the parabola. I can switch those points. So 0, 2 goes to 2, 0. 1, 3 goes to 3, 1. And 2, 6 goes to 6, 2. And that is the inverse. So now let's answer the questions. If 1, 3 lies on the graph of f, then which point lies on the graph of the inverse? We know that will be 3, 1. So if the derivative of 1 of the function at 1, the slope we found to be 2, then the slope of the tangent line of the inverse is now the reciprocal, as shown by our previous example. And that's the idea you need to come with. The relationship is they are the reciprocal. And next time we're going to look at inverse trig functions and investigate more on this process.